Hello, students. Now, this will be also a lecture of week one. And then I thought that yesterday I have done ABC, and then will this be the fourth lecture? And yes, let's see what to do. We have done P1, P2, and P3 of Adams, and now I want to do P4. That is the idea to do, and maybe some part of P5. And I don't know exactly, but how far I come and what I can do within just a half an hour, we will see. P4, that goes about functions, and I have to look in Adams, and I don't know how they call, yeah, functions and their graphs. So P4, functions and their graphs. Okay, but first of all, we have to define what is a function. That's of importance, otherwise we cannot do something. Now, function, let's call it f. Now, most of the time that function goes, you put something in and you get something out of it, and that if you have a very familiar function, it goes from the real number. So the function, it you can put a real number in it and you get some real number out of it. Now, the first part, this what you can put into a function, those values are called the domain of the function. And as I have written here, I can put everything in it what I want, so every real number, but most of the time that's not the case. We will see some examples. And what you get out of it, that is called the range of f. And here in certain sense is written that you can get every real number out of it what you want. Now that is not always the case, we shall see. But so if you have a function, if you have some function f, of importance are the domain and the range. So the domain is of importance. Let me write it by with it, the domain and the range of f. And I don't know if there is given something how to give a range, but otherwise we do it ourselves by some 3 letters or so. The range of f. No. That is of importance. And then you have a graph of f. So function of importance are the domain and the range. And then you have a graph. And what is a graph? You can make a graph. If you have a function, you can make a graph, and that function, the graph exists out of points x, fx. So, and x is from your domain of f, and f that is out of the range. So those points that give the graph of f. So if you have some function given, now what can you then do? You can make some sketch, you can make some graph of it. The horizontal axis is the x-axis, that is your domain. The vertical axis is your range, that is the y-axis. And so you can, for every point on the x-axis, you can calculate the function value. So if you have here some x, you can calculate is the function value. Now, and if you do that for all values of x, you get something like this. And yeah, now I'm and what do I now? Now I don't put my pencil off the paper, but maybe you have strange functions that you have to put the pencil off your paper, and then maybe you can not held your pencil at all on your paper. So okay, this is now a function, and here is written the y is equal to fx. So the graph satisfies some equation, and that equation, that is the y is fx. And you see for every x one value, yeah, one value in the range. And that is of importance. For every x, one value in the range. So if I have the following, so if you have here the x-axis and here the y-axis, and here I have some other figure like this, this is not a graph of a function. What you see here is that you have some value of x here, then you can in certain sense you can choose between two values, and that is not the case. So this is not a graph, and be careful with that. So here you have an example that it is not a graph. Here you have a graph, and here not a graph. Be careful. So if you have circles in the xy plane and ellipse and that kind of things, hyperbolas, just I have done in P3, those figures are not graphs of a function. Sometimes yes, sometimes not. No, sometimes I have said to you already from here. I have at the begin. I told you from a function from the real numbers to the real numbers, but most of the time you have to be careful. You have to see from what values can I fill in. For instance, if I have some function, if you are writing it in a nice sense, you are always writing this function and then points, then you have some x, and then you say to this x, they will give you the value, for instance, the square root of 1 minus x squared. And here you have some function. And on another way written, but that is not such a nice way, that is that fx is an is equal to 1 minus x squared. In certain sense, here you have an equation because you are writing here that f has to be equal to something. So this is the nice way, but we shall often use this. But if you are a real mathematician, then you will say, no, then you think, no, that is not nice done. But okay. Then you have to see from, in this case, what is your domain. First of all, I should say, always read an exercise or other things to see if the domain is already given or not. And if it is not given, then you have to search yourself for it. Now, and what do we know? You can only you have the square root, and if you fill in here, only exists if that x is greater or equal to 0. So and so we see that 1 minus x squared has to be greater or equal to 0, and that means that x squared has to be less or equal 1, and so we see that the x has to be less than 1 and greater or equal to minus 1. So here you see, here if the domain is not given, you see here that the domain of f is equal to, and then you get that sentence that are all real numbers such that x is greater or equal minus 1 and less or equal to 1. So that is your domain of f. Then we come to some other point. If you have the square root of x, the range will be positive. If it exists, if that square root exists, the square root is always positive defined. That is your definition of the square root of x. And so we have in this case here, but that is in a certain sense, we are coming to it in P5 or later on. But if you have the definition of the square root is in certain, you have here the graph of the square root. Here you have the square root of x. So graph of the square root. So we have there, so you have the points x, square root of x, and see what happens here in the neighborhood. You see that if you have an eyeglass on it, the function goes first along, is tangent to the y-axis and then goes up. So be careful and not otherwise. So tangent to the y-axis. And further on, that function goes to infinity. So yeah, the square root of x goes to infinity, so it keeps increasing. And if you follow that x, if you let the x go to infinity, yeah, you will never see that y also goes to infinity. So now the light goes on. I mean, in in my room. So if I not move, then it will go, the light goes out. But okay, that doesn't matter. Okay. Now, if you have now a circle, an equation of a circle, x squared plus y squared is equal to 1. Yeah, what is then the case? Then you can write down that your y squared is equal to 1 minus x squared. And we know already that will only and the squared, the x squared is always positive. And then you have, in certain sense, you have two functions. You have a function which will give you the plus the square root of x, and another function which will give you minus the square root of 1 minus x squared. And so you have two functions. And here we have a little sketch. You have minus 1 plus 1 in 0, it will be 1. And so it goes up, goes to the point on the y-axis, and then that. And I also write also down some name to those axes. So this is the graph of f1. And beneath here, that is the following. You have here plus 1, minus 1, plus 1. We have some y-axis, we have 0. And here we have minus 1 if x is 0. And that function goes on this way here. And so here we have y is f2 of x. So you have two graphs. So we have one equation. And if you want to describe your f, you have in certain, if your y variable as a function of x, you have in certain sense, you have two functions. Now, then we have some other functions, for instance, and then we are writing it not on the mathematical way. F is the sine of x, and then in Adams, look to all those graphs, and you have to, and please, a lot of those functions you have to know how their graphs are, so that you know how those functions behave. Now, what is the sine doing? I know that the sine of x is always less or equal to 1 and greater or equal to minus 1. So I can already give some bounds. In a certain sense, I know already where my range will be. That will be between minus 1 and 1. Now, if you fill in 0, the sine of 0 is equal to 0. That is going here. And then there are also other zeros of that sine function, and I think pi and 2 pi, you have minus pi and minus 2 pi. Now go so on. And what is further on of importance, that function goes straight through the origin. So I do it with some other color, that's maybe better. It will go straight to the origin, and here it will be in pi divided by 2, it will be equal to 1, and then straight through that other point, and here between it will become -1 and goes up. And so you get your graph, a sketch of your graph. And you see I can do it without any calculator or so. I just make some sketch, and I like that sketch. And try also to do it yourself in the same way as I am doing now. Sketch those figures, and later on you can always look to some other functions. For instance, nice program you can use, but that you can download and install also on Windows. WX Maxima. That is then you have a program for yourself on your laptop or your PC, and another program you can do with the sorry with Google. You can do Wolfram Alpha. That is a certain part of the program is given free, and so you can do a lot of things with those programs to make graphs and other things. What we are doing, what we will do in the coming weeks and months, you can do with those programs here. So this one Google, I mean search with progress, search with Google to Wolfram Alpha. And you can search with Google. So if you use if you Google and you search for WX Maxima, you will find the program, and the same for Wolfram Alpha. So search on internet, and you will see some nice things. Further, I have not told you yet, but that is of importance. The variables we use are dimensionless. And I think that is of importance. So, for instance, I have put some time. You can do the sine of t, and then you can think t is the time, and then you can think what will then be the sine of the time. Now, if your t is small, you can approximate your sine by t minus t to the power 3 divided by 3 faculty, and that will be 3 times 2 times 1, and plus t to the power 5 divided by 5 faculty, and 5 faculty will be 5 times 4 times 3 times 1. Now, and you can go higher. If your t is small, this will give you an approximation, and then look to those things which are written here. Here you have t, there you have t to the power 3, and there you have t to the power 5. If t is time, then you can ask yourself, uh, yeah, what is then t to the power 3 and t to the power 5? Can I add them together? Or if you think x is meter, what is then x squared, and what is then this here? Here you have length, here you have area, and here you have some volume. And how can I add length and areas and volume together? So therefore our variables are dimensionless, and that is of importance. And if you have ever a problem and you want to describe it, make your problem dimensionless. And you can do this by, for instance, t divided by some periods. And then this one is dimensionless, or um, for instance, x divided by L, and an L some length scale. And then you have those variables that t divided by t and x divided by L, those variables are dimensionless. And it is very good to, if you have ever a problem, to work with dimensionless variables. Now, I will not say something about it, but be careful and think. Um, yeah, think if you ask somebody how much do you run, and he answers, he or she, 40. Now, what do you think? And yeah, 40 centimeters, 40 meters, 40 kilometers, or otherwise. In certain sense, I think that you assume the last one, and so you have, yeah, in certain sense you have here a kind of dimensionless number. Maybe the person has done the following: he is measuring in meters, so he has 40 uh, 40,000 meters, and he has a length scale of some 1,000 meters, and so he comes to 40. So his length scale is just 1 kilometer. And yeah, the strange thing is that when he answers 40, that you think already in kilometers, but if yeah, okay, that is about the length scales and so on. Um, um, and what will I do more? Now you have also some strange function of function with a certain and that you already see also. Maybe we can define already. Uh, Sometimes you have a strange behavior of functions. Sometimes you have the feeling that you can, in certain sense, mirror your graph of the right hand side of your x-axis to the left hand side, so that the f of minus x is equal to the f of x. And if this is the case, f is even. That is called even. And if you have that the f of minus x is equal minus the f of x, f is odd. So if you have this here, and if you have this one here, your f is odd. And yeah, we can some graphs, for instance, if you have here the x-axis and there the y-axis, and here you have the graph of y is x squared. Now that you see that you can mirror that point. If you have here x, you will have the same value for the minus x, and so you can uh, mirror the function in the y-axis. You have both sides. So this f is even. And for some other one, to have some idea, for instance, this function here, and you will not have always that you have an horizontal tangent line in 0. That has not to be the case. For instance, here y is x to the power 3. This one is f is odd. And you have you know minus x to the power 3 is equal to minus x to the power 3. So you have here your x variable. Then you have here your function value. And if you have here your minus x, you see here. So here you have the length of these parts are equal. maybe I can better do some other color. You see here with the odd function that those things are the same, and with the even functions these are the same. And with the odd function, in a certain sense you mirror it in the x-axis, and then you mirror it in the y-axis. You are mirroring it twice. Now this is enough for this week, and then next week we will start with P5.